So the technique that we use with the stars and bars can also be used to solve certain kind of integer equations. Here's a particular example, and I think it'll be enough to illustrate the idea. How many different non-negative integer solutions does the equation below have? So the requirement here is that these are all integers, whole numbers. The non-negative means they can be 0, so greater than or equal to 0. And we're going to distinguish which value x1 has. x2, it's 3, it's 4. So for example, this first thing I've written down here is one solution, but over here this is different because in the first one x1 is 8, whereas over here x1 is 6. So those are different solutions in the way we'll count it. You don't really have to think about it that way if you understand the technique that we're going to use here. So the idea is that there's 23 tally marks, if you like, that we have to make here. We have to count what x1 is, and so we could count x1, for example, in the first case is 1, 2, 3, 4, 5, 6, 7, 8. x2 is 1, 2, 3, 4, 5, 6. x3 is 1, 2, 3, 4. And x4 is 1, 2, 3, 4, 5. So there's like 23 tally marks, which we can model by having 23 stars. And we'll distribute those stars to boxes more than, using tallies like I have there. So x1 box gets so many stars, x2 box gets so many stars, x3 box gets so many stars, and the x4 box gets so many stars. And that way the number of stars adds up, right, to 23, and it tells us what each of the x1s is. So one solution might be, for example, here's 23 stars right here, up here at this line. Each of those is 3 lines of 23, so we can do this a couple of times. But in the first case here, let's just say, okay, we're going to take 23 stars and draw some bars here to give us a solution. So for example, I might draw a bar here, and I'll draw another bar here, and then maybe I'll draw a bar here. And so now I've got 3 bars, which is all I need to separate this into x1, x2, x3, x4. So in this case here, I have x1 is equal to 1, 2, 3, 4, 5, 6, 7. x2 is 1. x3 is 2, 4, 6, 8, 9. And x4 is 6. Okay, that's the solution that this string of marks models. And that is 23. Another one might do something crazy like this. What is this solution? 3 bars right there. That solution would correspond to x1 equals 0 equals x2 equals x3, and x4 is equal to 23. Yeah, everything's in the x4 bin, so to speak. So that's how that's working right there. I think maybe that gives you a good enough idea that what we have is 23 objects in 4 categories. So this is the N and 4 is the R, and we'll get 23 plus 4 minus 1 using the binomial coefficient notation, and here's 4 minus 1, or 26 choose 3, like so. So that's how many different solutions there are of that problem there. Now while we're here, we might as well put a variation on it and say, well, how many of these satisfy the property? How many satisfy x1 is greater than or equal to, I don't know, let's just pick a number. x1 is greater than or equal to 3, and x2 is greater than or equal to, I don't know, say 5. Well, the way we can think about that is that x1 could be 3 or 4 or 5 or 6 or whatever, but we're saying it has to be at least 3, so we can start by saying the bins that we have that I drew over here have 3 stars in them to begin with. We have to dedicate 3 stars. And for x2, I have to dedicate 5 stars. I'm going to change the color so it's a little more clear here. So 1, 2, 3, 4, 5 here. And now let me just draw a line here, and that means that we have to take the other 23 minus 8, which is 15, and distribute that among the 4 categories. It works the same way now, except now we'll have 15 stars. That would be our new value of n, and r is still 4, and so we'd have 15 plus 4 minus 1 over 4 minus 1, or choose 4 minus 1, so it'd be 18, choose 3 solutions for that. There's a lot of other things we can do with this type of problem, but that's gives you kind of an idea, and we'll do some of these in class. So for example, in class we might say, okay, what if we turn that inequality around? What's the effect of that? So I'll just state this right here. How many satisfy x1 is less than or equal to 3, and x2, let's just leave it for the 1. So you think about that and maybe try to come up with something, and we'll do that one in class. Another problem that's like this, the ones that we've done here, and it's really maybe closer to the Skittle one when you think about it, but I'll write it down here, and we'll do one like this in class too. So you're going to buy a dozen donuts, 3 types. You know, you're going to bring it to share with your friends or whatever. So 3 types. I don't know what kind of donuts you like. Seems like glazed donuts are still #1 in the world. But, you know, chocolate donut, maybe that's the 2nd type. And the 3rd type might be maybe a cake donut. So those 3 types, you're going to buy a dozen of those. How many ways can you do that? So there's at least one of each type. Okay? At least one each type. So how many ways? I mean, it's like this problem above, and so again, we'll do one or more like that in class on an in-class worksheet. So that gives you a little bit of a look ahead at some of the kinds of problems we'll be doing with this stars and bars technique. Okay, we'll stop there.